Alright, here we go. I've got this ugly looking drawing here. And it's at the bottom. Now, what is this? This is just the base of it, okay? And it's not just a cylinder this time. It doesn't just go straight up in the air. And there's no way in the world I'm going to try to draw this three-dimensionally. It was tough enough to draw this ugly thing right here. So what what you have to do is look at the bottom of 19. Do you see the first shaded picture? See the one on the left? That kind of looks like what I just drew. And then you got that one in the middle. That would be if it was a cylinder. So if I was going to find the volume of this, let's say those sides went completely straight up in the air and flat on the top. How would I find the volume? Oops. How would I find the volume of that thing? Do you remember what the volume was? Yesterday's lesson? The volume. That's it. It's the area. I'll just write it all out. Area of the base times the height. Okay, so that would be the volume of what? A cylinder, right? So if it went straight up and flat on the top, the same as on the bottom, so if the top and the bottom are exactly the same, that would be a cylinder. And that's all that you would have to do. You just have to find the area of this crazy looking thing right here, then multiply it by how tall it is. Okay, and they'll tell you how tall the thing is. It's not written here, but we'll see in a second. Let me flip the page. What do they say? The height is 12. Oh, it does say at the bottom. Yep, it says it's 12 inches high. So let's actually write that in there. The height is 12 inches high. All right. But the thing is, look at the picture next to that one on the bottom, page 19. It comes to a point, doesn't it? It's got this base, but all the sides, they kind of slant, and they all slant up to one point, to one common point, so that all the sides come up to one point right there. So we don't call that a cylinder. What do we call that? A cone, okay? Or if you had straight sides, which actually you do have a few straight sides, it's kind of a combination of a cone and a what? Let's say they were all straight sides at the bottom and they came up to a point. What would you call that thing? A pyramid. Good. All right, so it's kind of like a combination cone slash pyramid, right? Because you got some curved things coming up, sides coming up, and you got some straight sides going up to a point. So this thing, again, we're kind of looking at it. This is kind of like the footprint. You know, you understand what I mean? This is what it's sitting on. All right, this is the base of it right there. And then it rises up and it comes to a point. So it's a three-dimensional thing, and the sides all rise up and come to a point. And that would be a pyramid or a cone. Now, how do we find the volume? What's the only difference between the volume of a cylinder and the volume of a cone? What's the only difference? It's it. It's just 1/3 of this. So you could put a 1/3 out front, or you could just do this. Just divide by 3. It's the same exact thing. So really, the equations aren't that much more difficult, are they? So if you know how to find the volume of a cylinder, you should be able to find the volume of a cone. All you do is just take 1/3 of it. Remember we took that piece of wood yesterday and I compared the two, and I said if you stuck that cone inside of the cylinder, then it would take up how much of it? It would just take up 1/3 of that whole entire cylinder. Does that make sense? All right, so that's why you divide by 3. All right, and now we can figure this out. So it's really not all that hard. Really, all the work is just doing what? Finding the area of the base of this. You with me? Okay, so let's do this. Let's do this big. It's supposed to be a semicircle. It's kind of ugly looking. I did it freehand, but this is a semicircle, and we want to find the area of that semicircle. So let's do some work on this. Let's make this black, easier to read. So let's find the area of this semicircle right here, and we're going to do them all. So how many different things do we have to find the area of? We got this semicircle, we got the smaller one, we've got what? This triangle inside here, and we got this triangle down here at the bottom. All right, if we can find all of those, we all add them up, multiply them by 12, which is the height, then take that whole thing and divide it by 3. Got it? All right, so let's do it. Let's find the area of the semicircle. So it's pi r squared. It's a semicircle, so what do we do? Divided by 2. So let's keep everything in terms of pi until the very end, then we'll chuck it in a calculator. So what do we have? 25 pi, is that right? All right, because it's 5 squared over 2. All right, so that's this area right here. Let's do the other semicircle. What would this be? It would be pi times what? What's the radius of this semicircle? It's 3. Good, because from here to here is 6, so the radius is 3. So what would it be? It would be 9, wouldn't it? Over what? 2. So I've got 9 pi over 2. Let's add those up right now, just for fun. What's 25 and 9? 34 pi over 2. And let's just simplify this just to make my numbers real easy to work with. What's 34 divided by 2? 17 pi. So far, that's not my answer, is it? What is that? That's just the area of these two semicircles. You good so far? There's all kinds of ways you could have done this. You could have thrown it in the calculator, got decimal answers and all that. But look, I didn't even need a calculator at all for any of this stuff. All right, that's my goal, okay, is to work math problems without having to use a calculator. It really is. Some of you guys, your goal is, I hope I never have to do anything in my head. I want to always do stuff in a calculator, right? But you got to get away from that mindset. All right, so we took care of this semicircle. We took care of this one. Let's look at this right here. Tell me something about these two triangles, though. They're right triangles, and what else? Compare the two triangles to each other. Look, this is 6 and this is 8. What? This is 6 and this is 8. And they both have right angles in between. So they're both exactly the same, right? So really, we find one, then we do what? Yeah. Or really, remember what the area of a triangle is? It's base times height divided by 2, right? But yeah, just don't divide it by 2 because we got the same exact triangles, don't we? Right? Does that make any sense? So really, all I got to do is just go base times height. So what is that? 6 times 8, right? Right? Which is 48. And that's the two triangles together. So this is 24 and this is 24. Together, they're 48. Got it? Have we covered everything? Sure. We got the two semicircles, we got the two triangles, and so we just add them up. Oh, we got to do this. Multiply it by 12 and divide it by 3, right? So I've got 48 plus 17 pi. That's the area of the base. If you want to, I was seeing this. Watch. The height is what? 12. Well, what's 12 divided by 3? It's 4. So really, all I got to do is take this and do what to it? Multiply it by 4. I'm just looking at all kinds of different shortcut ways of doing this. You may not do it exactly like this. It's just when I see things, it pops in my head, and I'm like, oh, you can give that a try.
What's under the area equals base times height?
It's divided by 2. That would be for one triangle, but both of these triangles are exactly the same. So I didn't divide by 2, right? Because you got 2 of them. Basically, I multiplied this by 2. The 2 canceled out. You could do it all kinds of ways. I mean, you could have found this one, and what would this be? This would have been 24, right? What would this triangle be? 24. Together, what are they? They're 48. You know, do whatever way works for you. So now you can just take all this, plug all that stuff into a calculator, and let's see if I find the right problem here. Somebody do that. You want to do that real quick? Pop that in your calculator real quick, see what you get. Okay, do all that. Put all that in a calculator, see what you get. Hopefully you get like 3... Oh, I'm looking at the wrong problem. Hopefully you get about like 405 point something. Good. Now they say 6.4. Why do you think they say 6.4 instead? And you said 6.3. Yeah, they probably use the whole pi button, right? But that'd be fine. If you put 6.3, no problem. All right, it's not that far off. That you did it right. Okay, so that's what it is. This is volume. So this was in inches, I believe they said. All right. So what is it? Is it just inches? It's inches cubed. Volume is always cubed. And there it is. And there's your answer right there. Look, I only had to use my calculator one time, didn't I? All right, I did everything in my head. It wasn't that hard at all. Put it in terms of pi, and then when I got to this point right here, then I just plugged that in my calculator just once, and boom, I got my answer. Good to go. So really, that equation is not that hard, is it? So the volume of a cone is the area of the base times the height divided by 3, or 1/3 of it. That's all you got to remember. If this went straight up and down, you would just not divide by, you would just not divide by 3, would you? You would just multiply by 12, and that would be your answer. We good with that? All right, let's move on. Let's do another one. All right, here we go. Now we got a cone, right? Nice little picture of a cone. It's not perfect, but you get the idea. We'll kind of color that in. All right, so what we're going to do is we're going to do the surface area. Surface area, not volume, but the surface area. Because we already know how to do the volume, right? It's the area of the base times the height divided by 3, and you should be able to do this. This time we're going to do the surface area. So we're kind of backtracking a little bit, aren't we? All right, but this is a new equation that we're going to learn. So this is the surface area of a cone. All right, and let's think of what we have here. Well, we have the bottom, right? Think of a cone, right? It's not an ice cream cone where it's open on the top. It's flat on the bottom. You follow me? It's kind of covered up. All right, so we want to find the whole entire surface area of this thing. So what do we have? We've got the bottom, which is just what? If it's a right circular cone, then this is a circle. So we just find the area of a circle. So that would be the bottom. But what about the sides of it, though? That's the thing. It's not, remember when it was a cylinder, what was it? It was the lateral surface area was the perimeter of the base times the height. This is not the same thing because it slants up like this, so we can't use this. Here is the lateral surface area of a cone. All right, I'm going to write LSA. We okay with that now? So the lateral surface area. What am I talking about? I'm talking about all this area right in here. You follow me? Except for the bottom. Everything but the bottom. Lateral surface area is pi r L. All right, you know what pi is. You know what r is. What's r? It's the radius. Okay, it's from here to here. That would be the radius. Okay, what is the L, though? The L, well, it's, I guess they kind of use L for length, but they call it the slant height. Okay, L is the slant height. So L is from here to here. If I just said the height, remember what the height is to the base? The height is always perpendicular to the base. If I said the height, which we're going to use in another problem, not in this one, okay? If I use the height, it's from here straight down, perpendicular to the base. That would be the height. They use a different letter, L, for the slant height. The slant height goes from here and slanted down. So if you were sitting on top of this cone and you wanted to ride down, all the way down like this, that would be the slant height. Okay, it's slanted. Makes sense, doesn't it? That's the L. Everybody got that? So if you know those, then it's actually pretty easy to do. To find the lateral surface area, you just take pi times the radius times the slant height. That's the lateral surface area. But then you also have to add it to the base, the bottom of this. If you look at the middle of page 21, look at page 21, right in the middle, example 2.4. Do you see that? It says the radius of the base of a right circular cone, which we have right here, is 8. So let's do this in a different color so it stands out a little bit. So the radius is 8. That line right there is 8. It says the slant height is 10. So this L is 10. Then it says find the surface area of the cone. We're trying to find the entire surface area. So first thing I'm going to do, and I'll do this problem in red. First thing we're going to do is find the area of the bottom. Well, the bottom is a circle, so it's just pi r squared. So let's plug some stuff in. Put the 8 in for this, square r, what do you get? 64 pi, good. So the bottom is 64 pi. We're just going to leave that for right now. We're going to add to it in a second, all right, but let's just leave it like that. So we got the bottom. Now we got to find everything else, which is the lateral surface area. So now we do the lateral surface area is just pi times r times L. So the radius is 8 and the L, the slant height, is 10. So what is that? It's 80 pi. Now, what do we do with the bottom and what do we do with the lateral surface area? Just add them up, okay? So if you add them up, what do you get? It's 144 pi. And there you go. That's it. If you want to chuck that into a calculator, you can. In fact, if you look at the example in the book, they just leave it 144 pi, which is kind of nice because I really didn't have to do any real big time work on this, did I? I didn't have to chuck it in the calculator. I can just keep it like that. If you want to put that in a calculator and get a decimal, it's fine with me. But a lot of times you'll look in the back if it's an odd problem and they'll leave it in terms of pi, which is okay as well. Let's do another one similar to this. A little bit of a twist to it. I'm going to have to start another YouTube video though.